Ladies and gentlemen, welcome to another session of Nambane Academy. We are currently busy with a series of lessons. We are currently doing grade 11 physical sciences, of which I believe and I have known that history has taught me that indeed it's a challenging topic. So there was a homework activity that was given last week, Tuesday. So I am going to mark that, but I have also compiled nice multiple choice questions. The reason for multiple choice question is I don't want us to have a surprise shock when we deal with the multiple choice in the exam. So multiple choice, because it's part of assessment, it should also be part of the teaching. So today we are just going to mark that one activity that was given just now to see if we are improving in terms of understanding what is given to us. So kindly just remember the PDF notes were given to you, so I am not going to go through that. I am actually going to go straight into the activity that was given, and I think it was activity number 8, which is this one. So I am going to go into it very quickly, and I'm going now immediately after that allow few questions on the platforms that we are on. If there are no questions, then we'll immediately move into the multiple choice questions. After multiple choice questions, also discuss the multiple choice and try to build also a systematic way of approaching multiple choice. So that will be an idea. But remember, multiple choice is part of teaching and learning. Multiple choice enhances the knowledge of us having this long type of questions. So without wasting any time, let me strictly go into it. Thank you very much for everyone that submitted their answers. I really appreciate it because I can actually see improvement, but I also believe by the time you do this topic at your school, definitely you will start now seeing a greater improvement. Ladies and gentlemen, let me not waste time. A learner wants to use a 12-volt battery. Highlight 12-volt battery with a negligible internal resistance to operate a bulb. He uses the circuit below to obtain the desired potential difference for a bulb to glow. The resistance of the bulb is 5 ohm. When switch S is closed as shown in the diagram, the maximum power is now what? 5 watts. So where is this maximum power? The maximum power is actually at this particular bulb of ours. Now, the very first question says, explain in words what it means if a battery has an EMF of 12. Refer to energy and charge with relevant values in your answer. So what the examiner is trying to ask here is actually a definition of EMF. What did we say about the definition of EMF? We said now for the definition of EMF, we are actually saying it is the maximum energy that the battery has. So what can one say at 8.1? It's very easy. One can easily say at 8.1, the examiner wants us to refer to energy and charge. So the first part will be it's the maximum energy of 12 joules is given off to every 1 coulomb of a charge. So this makes it nice to understand that when we say a battery has an EMF of 12 volts, we are actually saying that battery can deliver a maximum of 12 joules in terms of energy, but that it is now given for every single charge. So that is very, very important to understand. Hence, the guidance here is refer to energy, refer to charge. So when we refer to energy, it's the maximum energy that the battery can give. But when is it giving this particular charge? It is giving that charge to 1 coulomb of a charge. That is the reason why now this one will become 2 marks. 8.2 is Ohm's law. I will not waste time with Ohm's law. We spoke about Ohm's law. It is a non-negotiable. It is the law that each and every one of us must know. Very, very, very important. Furthermore, let's go now to 8.3. Calculate the current in the bulb. I said, let's redraw the circuit or have a way of highlighting the current flow. I am going to start the current flow. Let me increase it a little bit. Let me use green. The current flow will flow from this direction to this direction. And when it gets here, it will split now into two. I'm going to stop it here. So already it basically says me analyzing this circuit, one can say I have a junction here, and this junction basically tells me that it is a junction in which the current breaks into two. But the current passing at 3 ohm and the current passing at 11 ohm is the same current. So what can one do? One can somehow maybe combine 11 and 3 to make just one resistor. Why? Because 3 and 11 are connected in series. It's just me analyzing the circuit. Furthermore, when I look at 4 ohm and Y, the current passing at 4 ohm and the current passing at Y, they are actually the same current. Can one now use those basic principles of series and parallel? Definitely. So 4 plus Y is actually one resistor. So I am going to redraw this circuit for the purpose of explanation. I am not now answering the question. I am analyzing the circuit for us to understand. I am going to say fine, the circuit will look something like this, where I am going to have X, which is the bulb. I am going to have the battery that is giving me the EMF of 12 volts. But remember, EMF is the maximum energy that can be given off by the battery when the switch is open. So let's see, after redrawing this circuit, how is it going to look like? It is going to look like battery, bulb, 14 plus 4 plus Y. Allow me to draw it now quickly. Let me reserve the space for writing the answers. I'm going to just next to it have something like this. This will be my 12V. Move there. Have my X. Move there. Have now this one. This one I'm going to call it 4 plus Y. Come to this side. I am going to call this one something like 14. That is now 3 plus 11. And then this combined just gives me now something that comes there. It's fine. Does not really matter. Or maybe let me draw it nicer and just use something like this. 100%. Does it look like something that we can work with? Definitely. It basically says I have 14 and 4 plus y, which are just parallel to each other. So that critical thinking is what I want us to have and share. After that, the examiner tells us here we have 5 ohms, and the maximum power at the battery, we are told it is also 5 watts. So where am I in the circuit? I am at the bulb. So remember, I said you need to tell us where are you in the circuit. So if you are in the bulb, what does that say? It says you have P, which is equals to 5W. You have now R, which is just equals to 5 ohm. What is the question? The question is just current in this particular question. So, sorry, if this is the information we have, most of you used Ohm's law. Yes, you will be tempted to use Ohm's law because now you have R, you have the 12V. The 12V, ladies and gentlemen, it's not for the W or the bulb, sorry. The 12 ohm is not for 14 ohm or 4 plus Y resistor. Why? Because we said now if we have V total, let me maybe write it here. V total will be Vs plus now Vp. So it basically says now this 12 is going to be divided into the Vs, which will be the V at 5O or at the bulb, which will be the Vp where at 14 and 4 plus y. That is the reason why you did not get it right, because you did not apply the basic principles. Which basic principles? That this is actually V total. So V total does not represent the actual voltage at the bulb, because this 12 is being shared by resistors in parallel as well as the resistor, which is the bulb, in series. So hence now you did not understand and get it right. So by doing this, it's easy. P is equals to I squared R, and we want I, we know this is 5, and you divide by that, you eventually get a square root of 1, because you divide both sides by 5, and square root of 1 is just 1. And remember, you only get 1 mark for the formula, provided you attempt it. But now R is equals to V over I. There's no mark for that because it is an irrelevant formula. It does not assist you in terms of getting the current that is passing at 5 ohm. So remember, follow the current path. Look into the information that it's given. The information that is given will assist you to know in terms of the analysis of the diagram itself. So most of you made a mistake by using the 12V. And 12V, like I just explained, it is the V total of the circuit, but that is being shared by Vs and Vp. So I'm going to say square root of 1 squared, and I is equals to 1 ampere. So what do I know now? I can take my red pen and say I know the current passing here is a 1A. Then I am going to get 1 for the whole substitution there, 1 for the final answer, with the correct SI unit will give me the 3 that is required. Now, ladies and gentlemen, this one, it's somehow easy. It's not easy. It becomes easy because we used the basic principles. So you deserve your 30 seconds to digest, and then we get to 8.4. At 8.4, majority of you got it very wrong, unfortunately, but only because of you did not have the systematic approach. So I am going to give you an opportunity to digest 8.3 for the next 30 seconds. While you are digesting that, we prepare now to get into 8.4. It is 7 marks for a reason, ladies and gentlemen. It is 7 marks intentionally so, because it incorporates the basics together with proper analysis of what we call circuit understanding. So the circuit understanding is what Ntate Nambane drew. How did I come about this? It's me just following the current path and trying to have a simple circuit that one can be used to. A simple circuit that I can be able to visualize and apply all my important uh, principles thereof. So, Bonolo, your hand is up. Kindly ask your question.
Sir, may you please repeat the explanation of why the 12 volts are not used at the 5 ohm bulb?
Okay. Do you see the diagram that I just drew? Ne? It says V total is equals to Vs plus Vp. Because remember, we have now a combination of two, I don't want to say two circuits, but we have a combination, a parallel combination that is 14 and 4 plus Y. Those are two resistors that are in parallel. Then we have another resistor, which is the bulb. Ne? So the bulb is connected in series. So once you have that, it basically says the total voltage, it's divided for what? For parallel, it's also divided for series. So it basically says you cannot say at 5 ohm resistor or the bulb, you have 12. You actually have less than 12. Why? Because parallel combination is taking some of the potential difference. Series combination also takes another potential difference, but them combined, they give you now the total voltage of the circuit. So that is the only reason why we cannot use 12 there, because we have two combinations, series and parallel. So for us to know that what is the total, we need to combine the potential difference across resistors in parallel and the resistors in series. Follow up question, Bonol, please.
Thank you, sir.
Is it clear now?
Yes, sir.
Thank you very much. Ladies and gentlemen, let me give you your deserved 30 seconds such that I can allow you to ask other questions. That will be very, very, very important for you to do so. 30 seconds. It should be starting now. Go. Thank you very much. Let me look into. I don't see any hands, so I will just quickly move between this. I did not see any hands. Does that mean we are fine, ladies and gentlemen? Ratanang,
I'm fine, sir.
thank you very much. Ba Aneti,
I'm fine, sir.
thank you very much. Shanice,
I'm fine, sir.
thank you. Moteo,
Um, yes, I'm fine, sir.
thank you. The Honorable Mr. Nyokong,
I'm still good, sir.
thank you. And Lesedi,
I'm good, sir.
thank you. Ladies and gentlemen, if you are good, then let me try and move very fast and very quick. It says now at 7 or 8.4. 8.4. Let me use black. It says calculate the resistance of Ry. Okay. Ladies and gentlemen, I said it is always nice to know where are you in the circuit. So let me take the green, highlight the current path. I know the current passing here is 1 ohm. The current coming there, it's now also 1 ohm, but that 1 ohm will be divided now into 2. But what can I do now for me to be able to say something about 14 and 4 plus y? Remember, we said we follow the current path, and after following the current path, we will be able, or we will know for sure that it must include the current passing at the unknown. So let me quickly do that. If I can get the current passing here, I can actually get the voltage. And that voltage will be the same voltage that is shared by 4 plus y. And I will also know the current that is passing there. Because 4 plus y is actually resistance. That will be very easy for me to do. But let's check now if I understand clearly. It brings me now to what I have written down. I said refer to where are you in the circuit. So hence I will forever be referring that I'm at the bulb. I am at what is this? 14 ohm resistor. I will forever refer to a specific position inside the circuit itself. So this assists me in terms of ensuring now that I know where I am in the circuit. So let's not waste time and get straight into it. Can I calculate V at the bulb? Definitely I can. I have the current that is passing there. I have the resistance that is passing there. So if I get that, I can subtract that from the 12V and get now the resistance at 14 ohm. So what am I going to say? I am going to say I am at the bulb again. So if I am at the bulb, I am going to say what is it that I have? I have R, which is 5 ohm. I have I, which is 1 ampere. Can I get V? Yes, I can use Ohm's law now to calculate for that. Then I can easily say, but this is 5. I want V. I know this is 1. So V of series is actually 5 volts. That is very, very important. But what else do I know? I am going to write this one in red for purposes of emphasis. V total is equals to Vs plus Vp. Why? Because I have Vs, which represents the series section of the circuit. I have Vp, which now represents what? The parallel combination of the circuit. So this total I know is 12. This one is 5. I am interested in Vp. Why? Because if I can get the Vp, I can be able to calculate the current passing at 14 ohm. I can be able to calculate the current passing at what? 4 plus Y. And by so doing, I will be able to get the resistance of Y. Now, if this is done correctly, Vp should be equals to something like 7 volts. Let's write it on the circuit. V here is equals to 7 volts. What is V at 4 plus Y? Also 7 volts. Why? Because the potential difference across parallel resistors is the same. Then the circuit looks nice and easy. So can I be in a position now of saying, okay, fine. Immediately after that, where am I going? Let me go to add 14 ohm resistor. Hence, I always refer to where are you in the circuit. So at 14 ohm, what do we have? We have 14 ohm. Do we have V? Yes, it is 7V. Can we calculate the current passing there? Yes, we can. We can use R is equals to V over I, which is now 14. And this is 7 divided by current. And the current passing there, it's something like 0.5 amperes. So what is this current? It is the current passing at 40. Fine. So if this is the current passing at 14, 0.5. Quickly, Mr. Nyokong, if we have the current of 0.5 passing at 14, what is the current passing at 4 plus Y when our total is actually 1 ampere? Quickly, Ntate Nyokong.
It's 0.5.
0.5 say. Hence, ladies and gentlemen, it's easy now to see that we said the current is going to divide at this particular point. So once it is divided, and I have used this principle now of getting the current passing at 40, and I have now the current passing at 4 plus Y, which is 0.5. Do I have V that is passing, not passing there? Do I have V that I calculated there? Yes, I have V. I know that now V, because of 14 and 4 plus Y, and they are parallel to each other, definitely they must have now the same voltage. So I am going to calculate what? The total resistance of what? 4 plus Y. Let's see. Where am I in the circuit? Very, very important. And I will forever emphasize that. Let's take black and say, but now I am at 4 plus Y. What can I do? Do I have R? No, I don't. Do I have I? Yes, Mr. Nokon just said it is 0.5. Do I have V? Yes, it is 7V. Can I calculate R? R is equals to V over I. This becomes now 7 7 divided by 0.5, which will give you now R, which is just equals to 14 ohm. But now let's check what is this R. This R is actually a combination of 4 plus Y. Can I use my simple mathematics? Yes. R is equals to R. Okay, let's call it R of 4Y combined. It is R of 4 plus R of Y. Then this is 14. Then this is just 4. Then this is RY that I am looking for. Do the manipulation of mathematics. RY is just now equals to something like 10 ohm. Then this is how you get your 7 marks. Ladies and gentlemen, kindly feel free to ask me your questions. Let's start with Ratanang. Ratanang, questions please.
No, sir, I don't have any questions.
Then if there are no questions, what made it so little bit complex for you?
Sir, I don't know.
Once we cannot diagnose what is the problem, we will forever have a challenge. But Anetsi, why was it a challenge to you?
Sir, I think because my previous answer was wrong, I could not continue properly with the following question, which is why it made it hard. And I think I wasn't looking hard enough in my
S-
diagram, which is why.
So basically, my point is you did not analyze the circuit in detail.
Yes, sir.
Yes, hence I said, ladies and gentlemen, make this thing to become easy for you. Learn what we call circuit dynamics, how the circuit operates. Once you understand the operational system of the circuit, by only following the current path, I didn't do anything complex. The fact that I saw that the current passing at 3 ohm and 11 ohm is the same, I combined the two because it's parallel. I combined 4 plus y because y, it's actually in series with each other. Then it looked now simple because I have two resistors in parallel, one resistor in series. And now that becomes a basic way of doing things. Mr. Nyoko?
So, like, I don't think that I analyzed the circuit properly because, like, the correction seems like very simple, and then my answer was very wrong. I overcomplicated the whole thing.
Yes, you made the science very difficult. And my rule here is to make life very easy by giving you the basic ways of understanding the circuits. Bonolo Matosa?
So my approach to the question was completely wrong. I think I didn't simplify the circuit well, so I went in the wrong direction.
And now moving forward, how do you correct that?
I have to use your rules on how to answer the question, sir.
The question should be, why didn't you use them before? Thank you very much, Bonolo. Shanice?
Yeah, my mistake started with the previous question. Calculate the current in the bulb.
Mm,
Yeah, the 12 volts, and then my answer just went downhill from there.
okay.
Yeah,
So how do we correct it moving forward?
as you said, now analyze the diagram more and try to understand the question.
Okay.
Yeah.
Thank you very much. Moteo CDT.
Um, at 8.4. where there's the V total. Is it fine if you can explain from there? Because I'm still a bit lost.
V total.
Yes, sir.
Okay. What is the V total of the circuit from the information that is given?
12 volts.
12 volts. Now,
Oh.
how many sections do we have? Do we have series and parallel?
I think we have the answer for
Yes.
um
Now check. We have V, which is the total, ne? And we
yes,
have the
sir.
bulb. So the bulb will have its own potential difference because it's a device, okay? Now
Yes,
we
sir.
have the 14 ohm, which will have its own potential difference because it's another device. We have 4 plus Y, which is a resistor that will also have its own potential difference. So the potential difference of 14 and 4 plus Y is the same. Why? They are connected in parallel. And we have now the potential difference now there at the bulb. So we cannot necessarily say the potential difference at 5 ohm, which is the bulb, is actually 12V. No, because this 12 is being shared by what? The bulb and these two resistors. That's the reason why when we combine 5 plus 7 should actually give us the 12. Why? Because the 12 is the maximum potential difference that this particular battery can give us. So the key thing is check how many sections do you have. Do you have a parallel combination? If that is a yes, do you have a series connection? That is a yes. Then it basically says the V total, it's shared between the parallel and the series, but it is not going to be shared equally. My one will ask, but why? Because the combination of parallel, it's not the same as combination of the series. So hence it is always important to have that V total is actually equals to Vs plus Vp, where Vs is just now the potential difference of a series section. Vp becomes now what? The potential difference of Vp, which is the parallel section of the circuit. Yes, Moteo, follow-up question, please.
Yes. Yes, I understand that. And then also, at least I understand the 14 ohm. I want to also know at the 4
At
plus
4 plus
Y
y.
part.
Okay, let's look
Yes,
at
sir.
the diagram that I drew. Ne? Do
Okay,
you
sir.
do you agree the current passing at 4 plus y is 0.5?
Oh, yes, yes, sir.
Thank you. Because the total is 1 ampere, ne? And we calculated at 14 that the current passing at 14 is 0.5. So it basically says we are only left with another 0.5. So if that is the case, what is the V at 4 plus y? We said the V at 14 is 7 volts. So because 14 and 4 plus y are connected in parallel with each other, they actually have the same potential difference. Those basic rules we spoke about. So
Oh,
it
okay.
means now, yes, you have the current that is passing there, which is 0.5. You have now the potential difference, which is 7V. But now look into it. The R, which is equals to 40. What is that R? It is the total resistance of 4 plus y. So I made it easy here to say R of 4y, that means combined, is just now R of 4, that 4 as a standalone, plus now the ry, which is a standalone. Then 14 minus 4 should be equals to 10 ohms.
Okay. Thank you,
Okay.
sir.
Thank you very much for your question. No problem at all. Lisedi, comment, please.
Sir, I just learned that I need to just simplify the circuit for myself and to just analyze before I dive into the questions.
Thank you very much. That is very, very important. So what you guys do is you see the question, you are quick to answer 8.1, 8.2, 8.3 without actually doing what I said you must do, which is the operational way of the circuit dynamics. How does a circuit operate? How can you simplify the circuit in such a way that it becomes something that is somehow similar, or you have seen it before? If I were to ask you now, the diagram that I have drawn here, you have seen it before somewhere in your life of grade 8, 9, and 10 and 11. But now when we split it, you want not now to apply the principles. That is the reason why it will become complex rather now. That is the reason why Memory is saying it will also become a challenge, because we don't want to intend in terms of applying the basic principles. So I am happy that this actually happened, because it is an eye opener to everybody who's watching this particular session to say there are many ways of killing a cat, but the basic way is understanding the circuit dynamics. So once you understand the circuit dynamics until grade 12 level, because this is grade 11, that will become very, very easy. You can actually get total here for just understanding the operational dynamics of the circuit. Can I pass this one and go to 8.5?
Yes, sir.
Thank you very much, Mr. Nyokong. Let's quickly dive into 8.5, because now we have used almost 50 minutes in this one simple question. But remember, the idea is not to do a lot of things. The idea is just for you to get the crisp or the idea of how these things are being done. Let me copy this, because what I want to do is I want to refer to these values, but I don't think I'm going to need much. Let's just use a clean, nice sheet. It will save us time, because the question says now, calculate the cost to operate the bulb for a period of 1400 minutes if 1 unit of electricity is equals to 1 rand 80 cent. 1 rand 80 cent. It is that section that I said, cost of electricity. It is there, it will be there in the examination, because it is the integration of real life situation, especially now that we have load shedding, together with what? Together with the content that we are teaching. I gave you a formula, and the formula says cost is equals to kilowatt hour multiply by tariff. I said the formula will not be given in the formula sheet. You must know and memorize. That is very, very important. And that will assist you in terms of getting this particular 3 marks. Then let me not waste time and say cost is equals to kWh, that is now kilowatt hour, multiplied by the tariff. We said it says kWh. kW means now what? Means my power must be in kilowatts. So for me to move from watts to kilowatts, I must divide with 1000. So the first part will be at 8.5 will be cost is equals to kWh multiply by the tariff. But now it says kW, so 5 divided by 1000. Where is the 5? The maximum power of the battery there. Sorry, of the bulb. Multiply now by, it takes 1400 minutes. I said it must be in hours. How do we convert to hours? We divide now this by 60. Then we are just going to say 1400 divided by 60. And what did we say? We said the cost, which is the tariff, must be in rands. Then you just multiply this by 1,80, and this will give us something like the cost is 0,21 basically 21 cent. Let me just say that it will be just 21 cent for you to run this bulb for a period of 1400 minutes. Any questions relating to this one? Okay, I see a hand. Let me quickly check. Muteo?
So will the marker mark it wrong if you were to say 21 cent, not like 0.21 rand?
Remember they want it in rands, ne? So that 0,2 is very, very important. The only way of giving us, of giving you a mark, it is you having the R. The R is actually the SI unit of the cost they want to prefer. If you have something like 21 cents, I think it will be a little bit complex, because let me maybe emphasize it by saying, remember, if you are given this tariff in cents, you must also convert this tariff must be in rands, because you cannot move to your house and say, I want to buy electricity of 21 cents. It is always in rands somehow. So it must be in rand. That is a must. So even if we're given this as 50 cent, we're supposed to convert that 50 cent into a rand. So that tariff must be in rands. So it is important that your final answer now will be forced to become in rands, not in cents or something like that.
Okay, thank you, sir.
Thank you very much, and thank you. Ratanang?
Sir, please explain how you got the 5 divided by 1,000.
Okay, remember the maximum power that was given there, it's 5 watts, ne? Let me write it here. The maximum power that is given is 5 watts. But let's look at the formula. It says it must be kilowatts. I am here, Ratanang. Let's highlight. I am here. Maximum power is given as 5 5 watts. But the formula does not want us to use watts. It wants us to use kilowatts. So moving from watt to kilowatt, we divide by 1000. That is very, very important. And it says kilowatt hour here. This section here, it says hour. The H is for the hour. Let me maybe say this is kilowatt. The H stands for the hour. Our time is given now in minutes. So for one to move from minute to hour, what must they do? They must divide by 60. Hence, we have now 5 divided by 1000, 1400 divided by 60. The equation is straightforward to say it must be kilowatt hour, it must be the tariff in rands, then everything it is in the correct SI unit. If you were to use 5, 1400, you are not going to get that mark for the substitution. Only because the formula says kW, which is kilowatt. H, hour, not minutes. So it is important to be on the lookout for that, ladies and gentlemen. This is very, very important. Any other question? I don't see any hands. With that being said, I will say thank you. Let's go straight now to 8.6 because I see we are running out of time, but I don't want to rush these things. It is how it's supposed to be done, such that we can clear all the misconceptions, common errors, and build a solid foundation. Like I said, this is the last session for electric circuits. Next time when you get a question paper or a previous question paper that says anything about circuits, the thinking should be clear. So there are 3 videos available for this. Kindly try maybe when you have time just to revise. But you guys have a privilege of getting the PDF notes, so that will definitely assist us. Let's move. When we move, we say switch S is now open. Where is S? S is there. It's now open. This is S. So if S is open, what does this say? It says the current will move, and just move there. So it basically says we are only having resistors in series. Can you see that, ladies and gentlemen? Hence, follow the current path. If this switch is open, the current will flow in this direction. That direction, it will not come here to A, S, and B. It will flow through that, and we only have resistors in series, which will be 3 and 11. So what did we do basically? Let's read the question. Will the bulb still function at the maximum power? Write either yes or no, and use your answer without any doing, or explain your answer without doing any calculations. So the examiner doesn't want calculations. So if the examiner doesn't want any calculations, so what is the examiner saying exactly? The examiner is actually asking this. Allow me to go back. The examiner is actually asking about this. I'm going to edit it in purple or pink to say, just remember, just remember This I am going to call it the 3 ohm. This I am going to call it the 11 ohm. And I am going to add a bulb here and call it 5 ohm. Because our parallel section is dead. So actually what the examiner is trying to ask here is explain now the brightness of the bulb without using any calculations. So what can we do? We are going to say now, according to P is equals to I squared R, the greater the resistance, the greater the power for the same current, because the current passing at 5 is the same current passing at 3 ohm, is the same current passing at 11 ohm. But now P is equals to V, that means for the greater resistance, V also increases. But remember, what does this say now? It says the total resistance of the circuit actually increases according to P is equals to I squared R. The total current of the circuit decreases, and according to P is equals to VI and P is equals to I squared R, it will definitely decrease. So it will not perform at now its maximum current or power. This is what the examiner is asking. So it's the same question, but if you had no idea or clue in terms of, now I'm actually comparing in series because the section of 4 plus y is dead, then I am only referring to the power in terms of equations related to that. Hence I said keep the slide very, very safe. But the mere fact that I understand that the 5 ohm, the 3 ohm and the 11 ohm are in series, for me to get that maximum 4 marks, it's easy. I must just tell the examiner to say I am at 8.61. Let's use black and say now total resistance increases. And that is what we said. Connecting more resistors in series increases the total resistance of the circuit. Comma. According to what? According to P is equals to I squared R. Why? They are in series and the current passing at 5, the current passing at 3, and the current passing at 5 at 11, it's the same. Now, bullet number 2, I am going now just to say the total current of the circuit, total current of the circuit decreases according to P is equals to VI. Simple as that. And sorry, P is equals to I squared. So everything now is decreasing. The current is decreasing, or the current is the same, but it's decreasing now because of we have increased the resistance. So it basically says now the power will also decrease. So the final answer there is no, it will not. Now, one will ask, why did Nambane start with the explanation? Because we have what we call negative marking. Negative marking is what? If the correct answer is no, and you said yes with the correct reasons, we don't mark further. Everything is wrong. So our point of starting point in terms of marking is actually giving the correct answer. If your answer is correct, which is no in this instance, then we are going to consider the reasons that you are giving us. So start by first having an explanation. start by having an understanding of what is happening. So decreases according to P is equals to VI, and P is equals to I squared R. Power decreases, and the final answer is no. So how are we going to mark this? We are going to check your commitment for that 1 mark, and to say the total resistance increases according to that, and we are going to say now the total current decreases according to these equations, power decreases, and this becomes your four marks. Any questions relating to this? Thank you. Moteo.
Okay, so sir, wait, where do we receive our full mark? Oh wait, no, I see it, it's fine. Oh, I also wanted to ask another question, sir. So the direction of your current, right, is determined by whether the switch is opened or closed.
100%, because if the switch is open, it means there's no current flowing in that particular direction.
Oh, okay. Thank you,
Yes.
sir.
So me drawing it again in terms of the current path, it actually tells me the current passing at 5, at 3, and 11 is the same. So actually 5, 3, 11 are in series. So that assists me in terms of which equations I am going to use, which equations are more relevant, and how does now that influence the total resistance of the circuit.
Okay, thank you.
Thank you. And I repeat, operational dynamics of the circuit. That is going to assist us in terms of getting everything right. I don't see any hands. Let me check. Bonolo, are you fine?
I'm still fine, sir.
Thank you, Mr. Nyokong.
I'm still fine, sir.
Thank you very much. Shanice.
I'm still fine, sir.
Thank you very much. Memo Heseng. Thank you very much. Ladies and gentlemen, with that being said, let's go straight to 8.62. How does the potential difference across A and B compare with its value when switch S is closed? Okay, the switch S is now opened. That is now the statement at 8.6. Now at 8.62, how does the potential difference across A and B compare with its value when switch S is closed? Okay, so they want us to check the potential difference in terms of when the switch was closed between A and B, and now that the switch is open. Is it going to be greater? Is it going to be smaller than? Something like that. Definitely it is going to be greater than. Why? Resistors in series are increases, and the resistors in parallel are decreases. Let me maybe write it down in simple terms. Remember, easy note, sorry. Just moving to my whiteboard. Thank you. 8.62. Total resistance increases in series. Total resistance decreases in parallel. Now the question is, how does this assist me? One will easily say R is equals to V over I. So if R is smaller, it means V is also smaller. So when S is open, we only have resistors in series like we did. So the resistors in series give us actually R which is bigger. So for the bigger R increases, then it basically says V increases. So what will be the answer? Greater than. It is as simple as that. I said do not commit to greater than, less than, equal to, or 0 before having proper reasons why. Reasons, ladies and gentlemen, are a foundation of making a solid choice in terms of that. So you guys want to start with greater than, and then when the question is why, you don't have answers. So application of basic principles. So once the basic principles are done, it is easy for one to associate all the statements with the correct answer. So I am giving you this strategy. It will forever try to minimize the mistakes of committing without reasons. So have reasons, because reasons gives you now a solid foundation in terms of the final choice that you are going to have. And ladies and gentlemen, that is basically it with this particular question. So I am going to allow questions, and please comment in terms of this. I want us to have 40 seconds. What do we call it? Uh, for digesting everything that we spoke about, such that I can also hydrate, and because I feel like I've spoken a lot about this particular problem. So let's go and attend to your problems or questions that you might have. CDT.
Yes, sir. So let me just, can I ask first? So basically for 8.6.2, right?
Mm.
They wouldn't just give you two answers for free for just saying greater than.
Let's check. How does the potential difference across A and B compare with its value when the switch is closed? Choose your answer from greater than, less than, equal to, or 0. In this instance, if you said greater than, I was going to give you your 2 marks, because the question did not say explain your answer. But for me, I could not just go and say greater than without any reason. So remember, this is a lesson where we explain concepts of how we got to the answer. So it's the same strategy that I want you to use, because if you say greater than, why? Do you understand? In the near future, when somebody from somewhere in South Africa watches this recording, the question will be, how did they get to greater than? So I don't want to leave spaces for such questions. When you watch the lesson, you should go out of the lesson with proper understanding of each and every answer that was given in this particular session. So that will assist us a lot. But the answer is just greater than. So if you wrote greater than at your school, or if this was a test or an exam, greater than will definitely give you 2 marks. So there's no problem
Okay.
at all. Thank you very much. But I went further to explain why the answer should be greater than.
Okay. So can I just add that for my own understanding in an exam?
100%.
Okay. Thank
Thank,
you, sir.
thank you very much. Any other questions, Ratanang?
No, sir.
Thank you. Bonolo?
No, sir.
Thank you very much. If there are no questions, let me not waste time. It's exactly 1918, and we have not yet done what we're supposed to actually do for the day, which is practicing on the multiple choice question. Ladies and gentlemen, I am going to give you a maximum of 3 minutes per question. So be quick, analyze the circuit, send me your answer to my private number as much as you have it. Send it to me quickly, quickly, quickly. I'm only giving you a maximum of 3 minutes. I am not going, I'm immediately after 3 minutes. I discuss why that answer. At times, I want to go into detail, but I will see how best can I do that. But if the answer is straightforward, let's just choose the correct answer and move. So a maximum of 3 minutes per question. Analysis is very, very important. So we are going to build a skill of multiple choice. I believe that is clear. Without wasting any time, let's move to this one. And then I must have my timer ready at all times. Timer 3 minutes. Thank you very much. There are still 1, 2, 3, 4 answers outstanding. Kindly send your answers. Thank you. One received. Thank you. Thank you. There's one missing. 1, 2, 3, 4, 5. There's actually 2. Thank you. And there's one missing also. Okay, received. There's only one missing. Ladies and gentlemen, 1, 2, 3, 4, 5, 6. There's one missing. Let's patiently wait. Let's patiently wait. If this was an exam, yo, it was going to be bad, bad, bad results. And your parents will be fighting me to say, no, that number you did not teach or assist these learners in the best possible way. Thank you very much for your answers. Let's get straight into it. 3 light bulbs R or X, Y, and Z with the resistance R, 2R, and R are connected in a circuit shown below. The battery has a negligible resistance. The reading on the ammeter is 2,5 ampere. Okay, now we have what we call elimination method. So let's apply the elimination method immediately after reading the question. Follow the current path. Which one of the following correctly describes the reading on the ammeters when Z bends out? Ladies and gentlemen, when Z bends out, what does this mean when Z bends out? The current will come, split into 2. There will be no current moving into A3. Why? Because if this one dies, I repeat, if Z dies, no current will be passing at Z. So it basically says now, for everywhere where A3 is not 0, that answer automatically becomes very wrong. So C is an obvious distractor. That is what I call them. So look for your distractor. So the distractor in this instance is now what? It's C. Why is it C? Because we know there is no current passing at A3. Why? Because A3 bent out. So how will the current pass? There's no way. So C is definitely incorrect. Applying the basic principles. Follow the current path. Now let's look at B and D. We said A, definitely, sorry, not A. We said C, definitely wrong because of this particular failure. Now let's check. The current passing at X should be greater than the current passing at Y. Why? Because the resistance of Y is 2 times that of X. I want to do it in a form of explaining in terms of the calculation. Where am I? I am at X. R is equals to V over I. And I make this one equation 1. And now I am at Y. R is equals to V over I. But I am told that this is 2R V over I. I make I subject of the formula. I have V, which is 2R, and this just becomes half of V over R, which is just now what? I is equals to V over R. So it's half now of I. This is at Y, this is at X. So one can easily see the current passing at Y, it is half of that. So let's look for where is the half. If 0.75 is passing at A, and 0.275 is passing at B, that cannot be correct. We are looking for the half of A. So this automatically becomes incorrect. If 1.25 is passing at A1, we are looking for the half of 1.25. This one also becomes incorrect. So the correct answer must be A. If at 1, A1 is passing 1, then A2 must be half of that. A3 must be 0. Why? Because there's no current passing there. The rest of A, which is now 1.5, it basically says, remember, when we connect more resistors in series, in parallel, we are actually decreasing the resistance. So in this instance, what did we do? We killed one resistor bent out. So the mere fact that it bent out, it basically says we increased the resistance of this particular circuit. So the resistance increased, current decreases. So the correct answer, ladies and gentlemen, is A. I believe it is clear. Let me quickly just say, Bonolo, are you clear?
Yes, sir.
Shanice, are you clear?
Yes, sir.
Thank you. Then let's move, ladies and gentlemen, to this other one here. Another nice 3 minutes. Let me sort it out. Next time I will quickly go to Kahoot, and Kahoot will assist us in terms of grading. Remember to send the answers. That is very, very important. Very, very important. So I'm waiting for the system to respond. Once it responds, okay, there is a hand. Let's check Moteo.
So I still don't understand about the A in the A. Like you see the ammeter reading for
Mm,
A. I don't understand. Like I understand the A1 and A2, but not the A.
okay. Remember now, uh, X, Y, and Z are connected in parallel, ne?
Yes, sir.
So if Z dies, it basically says we are only left with two, that is X and Y. So we no longer have 3 resistors in parallel. We actually have 2 resistors in parallel. So what did we do? We increased the resistance of the circuit. Because if you have another one, the more resistors connected in series, in parallel, decreases the potential, decreases the total resistance of the circuit. Let me go to this slide. It will assist you and everybody that is in here. Hence, I said that slide, ladies and gentlemen, it is the mother of slides. It is this one, CDT. Adding more resistors in series increases the total resistance of the circuit. Adding more resistors in parallel decreases the total resistance of the circuit. So if we had 3 and we are left with 2, it means now it is going to increase the resistance. And once resistance increases, the current of the circuit decreases. So we used this to explain that. So when I was doing this, Mr. Nyokon said, Miner, this is basic things. We've been doing them from grade 8 until now. So hence I said this foundation is very, very important. Kindly go through again this particular PDF notes. With that being said, let's move to this one. Your 3 minutes should start now. One more answer. 1, 2, 3, 4, 5, 6. There's one missing.
Um,
Mateo.
sorry, sir. My phone just died. My
Uh,
phone just died.
okay,
So,
excuse ma'am. But what is your answer then? Just say it out loud.
it's B.
D
B.
or B. Okay.
Yes, sir.
Okay. Let's look into it. Let's look into it. Let's look into it. Multiple choice as part of teaching and learning. Ladies and gentlemen, let's read this question together. In the circuit represented below, internal resistance of the battery is negligible. Which one of the following combinations correctly represent changes in the reading of the voltmeter and ammeter when the copper wire is used to connect the two dots? There's only one person who got it right. Let's move and check. Let's have a line. And this line must start here and move there. That is what the examiner is saying. So what does that mean? Follow the current path. You did not do that. The current path will flow from there, here, and there. Ladies and gentlemen, current wants to flow with ease. It will not go to this other R because why? There's an option of going to a seamless direction. You see? So it will not go to the other R. So if it does not go to the other R, what does it mean? It means the R of the R total decreases. R total decreases. Maybe I should just take it, put it this side. R decreases, which is true. We are only left with 400 resistor, not 2. So when R decreases, what does this say? It says now I increases. Why does I increase? Ohm's law. The lower the resistance, the higher the current increases. What about V? V also increases because of the battery. Why? V increases for the same battery. So it basically says we are still going to have the same V. Remember what did we say when we have resistors in parallel, in series? They are potential dividers. So if they are potential dividers, potential difference will be divided to the first R, the other potential difference will be divided to the second R. But now it means the total potential difference will increase. Why will it increase? It will increase because the other R is no longer there. So the only correct answer here, ladies and gentlemen, is A. Voltmeter will increase. Ammeter will also increase. That is the correct answer for this particular one. That is the correct answer. So I'm just waiting for the system to respond, and it should save us time. It's exactly 1942, and but I believe everything should be clear. Increases, and then V increases for the same battery. So the correct answer is A, 100%. 2 marks. Then we move to this one. For this one, kindly tell me, I will give you still something like 3 minutes, but for both of them, because the first one is quite straightforward. It just wants you to apply. So I'm going to give you the 3 minutes for both of them. 3 minutes for both of them. So just make me aware which one is 1.9, which one is 1.10. Sorry. Three answers outstanding. Thank you. There's 1, 2, 3, 4. Okay, thank you. And then the last one should be, let's check. The last one should be Ratana. Yes. Hmm. Thank you, Ratana. Received. Let's look into the answers you gave. Let's look into the answers you gave. Let's start with 1.9. 1.9, which one of the following combinations of SI units represent an ohm? This one is easy. R is equals to V over I. What is now the SI unit for potential difference? Is V. What is now the SI unit of current? Is A. Can one easily say this is just V multiplied by A minus 1? So the correct answer there is D, ladies and gentlemen. Easy, 2 marks. So can you see all the basics are very, very important. So the correct answer is D. And lucky enough, I am not only choosing my answers, I am giving you reasons why these answers are correct. I am giving you the application, the operational plan that you need now to use actually when you get into the exam. So the multiple choice is basically now incorporating all the concepts of the topic. Hence, I said it is important that multiple choice should be taught as part of the actual class activity. Let's see at 1.10. The battery of the circuit diagram below has an EMF of 12 and negligible resistance. Two voltmeters V1 and V2 are connected as shown. What are the readings on V1 and V2 when switch S is open? Ladies and gentlemen, very easy this one. It can't be 12-12. It can't also be 0-0. Why? Because we have potential difference of the battery is there, 12. And why at A that Nambane says it cannot be 12-12? Because once we have the current flowing, that 12 of the battery will be divided at V2, will also be divided at this resistor here. So there's no way it can be the same as the potential difference of the battery or the EMF. So I am only left now with B and C. But what does that say? It says when the switch is open, the battery gives us the maximum EMF, which will be 12 volts. So this here is actually measuring the potential difference there. So 12 is an option. And when I look at C, 12 is the first option that I can get. Because there will be no current flowing to V2, then that should read 0. So the correct answer here must be C. The correct answer here must be C. And that now it is at 1.1.10. So it is what? Application of the circuit. Understanding how the circuit now operates. So the correct answer there is definitely C. Let me check the time. It's 19:52. I am going now to quickly give you the last one. We agree, ladies and gentlemen, the answer here is C. The explanation is very clear. So let me just quickly say, this one is quite easy. Let me give you 3 minutes for both of them. That is now 1.9 and 1.10. So your 3 minutes start now. And immediately after 3 minutes, we'll have the reflection of the day. And Shanice, you will be the first one giving us the reflection. So kindly prepare yourself such that by exactly 8 o'clock, we are done with this particular session. Thank you. So, okay, one, two, three, four, five. Two more missing. Okay, thank you very much. All answers received. Ladies and gentlemen, let's look into it. 1.9. 1.9 The kWh is an unit: energy, power, time, and force. From the equations, P is equals to W over T, where W is just energy or work, like we said, or work, and this is time, and the measure of time can be seconds, minutes, or even 1 hour. But this here now is power, and power is measured in watts. So if I manipulate the equation, obviously B is incorrect because power should be watts. Watts is joules per second. So B automatically becomes wrong. kWh, can it be time? Not true. Can it be force? Not true. Because if I want now W, it is going to be W is equals to PT. And what is PT? Is kW multiply by that. This will give us W, and the W is known as energy. So the correct answer here should be A. Nicely explained. At 1.10, the bubbles in the diagram or the bulbs in the diagram are identical. When switch S is closed, they close switch S. The current will flow. Current always chooses an easy way out. The current will flow from there, and just go straight there and go back. It will not go to Y. Why? Because current always chooses the lowest path in terms of resistance. So it will not go to that bulb. So it will say when switch S is closed, X and Y no longer burn. Incorrect. We work now with elimination method. We look for those two distractors, which are somehow completely incorrect. X and Y will no longer burn. Not true, because X will burn. The current is passing there. X and Y will burn with the same brightness. No, because the current is not passing at Y. Both bulbs burn, but X is brighter. No, because the current will pass at X and go to S, not go to Y. What does that mean? Only X will burn. So the only correct answer, ladies and gentlemen, in this particular one is B. B is the only correct answer. Ladies and gentlemen, thank you very much. That brings us to the end of today's session. It is exactly 20:02. So in the next 5 minutes, please, not 5 minutes, 3 minutes, I'm going to ask each and every one of you to give us a reflection of today's session. Remember, we use these reflections in order for us to improve. We use these reflections in order for us to design worksheets and e-notes, recording of sessions, such that in the near future, somebody, when they access this particular recording, they can easily understand it was actually the work that went into this. So I am going to start with Shanice, kindly, because this is the last session, unfortunately, of electric circuits. We will do electric circuits again towards the June exam when we revise. But for now, I think we have exhausted all the skills that I have in terms of this. The only thing that I can do is expose yourself to more exam type questions. I have given you the platform www.nambane academy. You get question papers, you get content material, you get everything that is as of assistance to you. So kindly use the platform. Don't be afraid. Share it with your friend, share it with anybody, because the idea is we want to assist as many people as we can, because the idea is to make your physical science journey very nice and entertaining. So feel free, share everything with anyone. If there's somebody that you know that needs support, introduce them to this platform. You know the registration process. Let them come. Let's build a community that is going to be self-driven, science knowledgeable, and can be able now to attempt all possible questions in the exam and eventually have this brighter future that we want to build. With that being said, let me give Shanice a platform in less than 10 seconds. Shanice, the platform is yours.
Manel, yeah, today's lesson, I don't know, when you do the corrections, it all comes so simple. But when I start doing it alone, I don't know, things happen. But yeah, today's lesson is great, I think. Yeah, thank you.
Thank you. How can I improve?
And no, there's no room for improvement. You're already better, Manel. Like, I think I'm the problem. Yeah.
Okay, thank you very much. Let's go to Mr. Nyokong.
So like I found this session to be very enlightening because like I now have like a better understanding of how circuits work and how or like how the current moves in a circuit, sir.
How,
Thank you.
thank you. How can I improve?
Um